Hi everyone, let's take a look at exercise 63. Root functions and root formulas and how they work. At exercise 63 they give you a function or formula. Y is 2 plus root x, and they want you to complete the table around to one decimal place where necessary. And they gave you a table with certain values, and luckily we can use a calculator here because some of those roots will not give us nice answers. That's why they say round to one decimal place when necessary. If you fill in x is 0, you get y is 2 plus root 0. Root 0 is 0 because 0 times itself is 0. 2 plus 0 is 2. Hey, when x is 0, y is 2. When x is 1, you get 2 plus root 1, which is 2 plus 1, which is 3. For us, if we want to fill in 2, you don't have to write in the calculation, right? But just so we know, that means that if x is 2, that will give that y is 2 plus root x, but x is 2, so this. And here we have to round, because root 2 is not a nice answer. And you can now take out your calculator and ask it to calculate what 2 plus root 2 is. So I'm doing that right now. I already know the root 2 is 1.41. You guys don't know that. Here, if you would round it, you would find approximately 3.4. So at 2, I'm approximately 3.4. And then you do the same with 3. So you do 2 plus root 3. And then you find, well, this is approximately 3.7. Root 4 I know, because root 4 is 2, 2 plus 2 is 4. So this is 4. Okay. For 5, again, root 5 we don't know, so do root 5 plus 2, and you find, and that's approximately 4.2. And now they skip out and go to 9, because root 9 is 3, 2 plus 3 is 5. That is A. And now they want us to draw this graph. They say the graph is a smooth curve, draw the graph. And I'm not going to draw a whole coordinate plane here, because the only things that I have are positive values for x and positive values for y. So instead of making the usual coordinate plane, which looks something like this, right, I'm focusing only on quadrant 1, the one where both are positive. And I know x goes to 9, so I can at least do 1, 2, 3, 4, 5, 6, 7, 8, 9. And I know y goes up to 5, so let's do 1, 2, 3, 4, 5. And oftentimes I do one higher for y, and I like that a bit more. But you can go to 5 as well. Number the axis. Here as well. There's still x and y axis, so call this axis x, this axis y. And now let's plot the points. This is point 0, 2. 0, 2 is right here. Then we got 1, 3, which is here. And then we have two which are a bit more difficult to plot. 2, 3, 4, which I guess is somewhere around here. 3, 3, 7, which I think is somewhere around here. 4 we know though, that's exactly 4. 5 is 4.2 something. And then we do know that 9 is at 5. And they say that this is a smooth curve, right? So I already see that this point should be a bit lower. Again, it's not that important if you make that mistake. And now you're going to draw the graph, which means I'm going to try and draw, and it's quite difficult on my drawing tablet to be very honest. I'm going to try and draw a line that goes through all points. You see, I find it difficult. Maybe I'll try using the, give me a second, using the touchscreen on my actual screen. I think that's, in this case, easier. Well, not by much, but I try my best. You guys can, of course, do better on paper with a pencil. But this is what they want you to do, and then at least try to get rid of the squiggly bits that I just rewrite. So in reality, it should look a lot more like something like this, right? And then through all the points nicely. And don't go downwards at the end. because this line will never go down again, because the higher values I fill in for x, the higher I'll become, but just not that quickly, right? Because the root is going to kind of hamper the growth of my y value. So this is a line that if you're going to make x is a lot longer, it keeps increasing, but very slowly. Write down the coordinates of the starting point. Yeah, the starting point is right here. The starting point in this case is 0, 2. And we're not going too much into depth about how this function works, but this function does not go right here, because if I would fill in x is -1, I'm filling a negative value for x, and we know that that is, when we're using real numbers, something that will not give me an answer. So this graph really has a starting point, and that's in 0, 2. Then let's take a look at exercise D. Now we're actually going to calculate a bit more with this stuff. Point P with x coordinate 2500 is on the graph. Calculate the y. Again, we practiced this with quadratic formulas. We practiced this with linear formulas. This doesn't work any different with radical functions, square root functions, sometimes also called root functions. If x is 2500, that gives me y is 2 plus, and just change the x into what they ask you to, in this case 2500. You can use a calculator for this exercise, right? So if you don't trust your skills, you can do it like that. Some people will see that, well, the root of 25 is 5, so the root of 2500 is 50, because 50 times 50 is 2500, so 52. So if x is 2500, y is 52, and you see how slowly this increases, right? If x is 2500, then y has only increased from here to 52. So this thing really is not going to grow quickly. So the y coordinate of P is 52. E. Use a calculation to find whether the point is on the graph. Okay, this is x, this is y. Again, you can notate this in different ways. You can say x is 110 and a quarter gives, and then fill it in and check if the y value is this. What you also can do is this notation, which I have shown you in class. This is more the notation we use in 3rd grade and up, but I prefer it over the way the book does it right now, and then change it for next thing. So first summarize, we have this and we have that. So, curly brackets, accolade, I change the y into 12.5, and I change the x into 110 and a fourth. And we can, using the skills that I've gave you, try to calculate this, because we can rewrite it as a whole fraction and then see if we can factorize it. But again, right now we can use the calculator, so I'm going to do that. It's apparently 10.5. 10.5 times 10.5 is 110 1/4. And here you find something that is true. 12.5 is 12.5. Hey, if this now works out, then that means, yes, Q is on the graph. Don't forget this conclusion. If I found anything else, for example 12.5 is 11.5, then it's not correct, then Q is not on the graph. Okay? F. And read carefully. Explain without a calculation why point R 15,6 is not on the graph. They don't say calculate. I can calculate it exactly the same way as we did here, and then you find that it's not on the graph, but I want you to explain it without calculating. And to do that, just take a look at the values of x and y. That means that in this formula I would change x into 15 and y into 6. And I get root 15. And we all know root 15 is not a root that gives a nice decimal number. It gives an infinite decimal number. Which means that even if I add to it, y is not going to be a whole number. So explain without a calculation, in this case would say, filling in x is 15 results in root 15 appearing in the formula. This is not the whole number. This is not the whole number. And if I'm very elaborate, I could now say, so this will not give me y is 6. And if I'm again I'm a bit working into the details, I could say not root 15 but results in 2 plus root 15, because we still have this 2 plus here, right? So fitting in x is 15 will result in 2 plus root 15 appearing in the formula. This is not a whole number, so this will never give me y is 6. I didn't do the calculation here, I didn't put this into my calculator, but I already know that. So even if it's 15 or 14 or 13 or 12 or 11 or 10, if it's 9 I should check, hey, then I get root 9 is 3, 2 plus 3, and I calculated that's not 6. But for all numbers that don't give me a nice whole number and filled in for root x, so almost all numbers, right, except 4 of 1, now I should say 0 as well, 0, 1, 4, 9, 16, 25, 36, 49, 64, etc. You don't have to check it, okay? And that's it. Good luck.